One of the primary mechanisms that we're told that drives evolution are mutations. All right, take a look at this slide here. Here we have a snake with two heads. Are two heads better than one? I mean, he may have a slight advantage from the standpoint that if a mouse runs by and in his first field of view he misses it, with his second field maybe he can leap and catch it, right? But you know, oftentimes with mutations what we find is there may be a slight benefit in a selected situation, but as a whole there's also a cost to it with these mutations. Think about him trying to get away from a predator. He's no longer streamlined, is he? If he's trying to get through that grass, he could easily hit a fork in the road and he would be stopped right in the midst. Take a look at this bull. How many legs does he have? He has 5, right? Now, are 5 legs better than 4? Not really. You know, this is a non-functional limb that he has here. He could get something underneath it. He could rub it and get it infected. He could have some problems based on this extra structure. Now, you know, for the farmer, this might be an advantage because now at the meat market, he's going to weigh a little bit more. But the reality is it doesn't help this organism himself. One of the things we also find with genetic engineering, we can make hairless tomatoes, seedless fruit, hornless cattle, right? Now that benefits us, doesn't it? Does it benefit the things where we see the mutations? No. So what we see with mutations, they're not necessarily anything that benefits the organism itself. What about the bald rooster? Does this guy have any real advantage? First of all, he's probably not going to get any girlfriends, right? Second of all, he's going to be much more vulnerable to environmental extremes. From the standpoint, if it's during the summer and he's hot outside, he's not going to be able to insulate himself when it gets really hot. He can easily get a sunburn, right? On the other side of it, if he's in a very cool environment, he could die of hypothermia. And it turns out that's exactly what happened to this guy. His siblings, who didn't have the mutation, who had the feathers, they did just fine, but he wasn't able to withstand the cold. The important thing to recognize with mutations themselves is they're not good things generally, they're bad things. Think for just a moment if we had another bad situation, a disaster, such as Chernobyl, where you basically had a nuclear reactor that melted down. Do you think scientists would tell you to go out there and just bask in the radiation laying on your lawn chairs? No way, right? Because even though that causes mutations, mutations aren't good. Well, the reality is, as Dr. Gary Parker puts it, with mutations, mutations are damaging, disfiguring, disabling, disease-causing, and deadly. Other than that, they're wonderful. Another requirement that you would expect from mutations, if they're going to drive evolution, would be that they would have to be able to add information to the DNA. If you think of what they tell us in evolution, everything started out with that first primordial cell. This would be the least complex of any creature that we know today. Right? So it wouldn't have a very sophisticated blueprint. If it went and evolved finally to the most complex, which is us, you'd expect there to be a lot of information that would have to be added to it. Information about encoding for our eye, for our teeth, for our brain, for our heart, our lungs, our liver, all those kind of things would have to be encoded now for humans versus what you had with that very first cell, right? But what we find when we look at DNA and mutations is that when mutations take place, these are mistakes in the DNA itself. They lose information. They never gain information. We know of no mutations that actually cause an increase of information where there's going to be a new innovative structure, such as an organ, such as a wing, such as a leg, or anything like that. So the bottom line is we don't see mutations fulfilling a requirement that would cause things to become more complex and more diversified as time actually goes on. So when we look at change from an evolutionary point of view, we do see minor change. It's not evolution, it's simply genetic diversity.